Welcome back. I want to go ahead and discuss the Lesson 3.1 notes, conditionals and counterexamples. A conditional is a statement that can be written in the form if P, then Q. An if-then statement is of the form if P, then Q, and we can use symbols to represent this. P arrow Q, read if P, then Q, or P implies Q. We say that the hypothesis of a conditional statement is the phrase immediately following the word if, which we will represent as P, and the conclusion of a conditional statement is the phrase immediately following the word then, which we will represent as the letter Q. So if we take a look at our model, P arrow Q or P implies Q, Q will be outside of this circle, or we can say that this circle P is inside of circle Q, and we will get into more information about that. Let's examine the following conditional statement. If I live in Austin, then I live in Texas. So, what is the hypothesis? What is the conclusion? We say, again, anything after the word if is our hypothesis, and anything after the word then is what we call our conclusion. So, here, I will say that the hypothesis is I live in Austin. And our conclusion is I live in Texas. Well, if I live in Austin, then of course I live in Texas. So we can take a look at this model here and we can think about the real world situation. Well, if I live in Austin, and obviously I will live in Texas, right? Texas is a state, and of course it contains the city. So let me write Texas. We can pretend that this outer circle here is the state, and what's inside is our cities. For instance, Austin, I can include or put inside of Texas, or if I say if I live in Dallas, then I live in Texas, which I can put inside of Texas, or this circle right here, or San Antonio, or El Paso, etc., etc. Let's go ahead and identify the hypothesis and conclusion of each conditional statement. Underline the hypothesis once and the conclusion twice. If it's rainy outside, then I bring an umbrella. Well, we can see that here's my if, and then there's my then. So I only need to underline the hypothesis once, and then I'm going to underline the conclusion twice. Number 2, if today is Thursday, then tomorrow is Friday. So the words after if is my hypothesis, then the words after then will be my conclusion. Number 3, if two lines form a right angle, then the lines are perpendicular. So again, this is our hypothesis, and then the stuff after the word then is our conclusion. Number 4, an angle is a right angle if the measure is 90 degrees. The structure is different from the previous questions. An angle is a right angle if the measure is 90 degrees. So again, the stuff after the word if will be our hypothesis, which I will underline once, and this will be our then. Even though it doesn't say then, it will imply that this is the case. Right, so this will be our then, even though it is written before the word if. Some conditional statements are written without using the words if and then. To write these statements in conditional form, you first need to identify the hypothesis and conclusion. For the following statements, identify the hypothesis, underline once, and the conclusion, underline twice, and then write the statement as an if-then conditional. Number 1, 16-year-olds are eligible to drive. So, first of all, we need a hypothesis and a conclusion. If you are 16, then you are eligible to drive. Number 2, the measure of an acute angle is between 0 and 90. This can go either way because the measure of an acute angle implies that the angle is between 0 and 90. But if we're talking about the measure of an angle, any angle is between 0 and 90, then it's an acute angle. So it goes either way, which we will call a biconditional. So let's write that down. Can go either way, since it is a definition. So really, both can be the if and both can be the then. Like I said, number one, if an angle is acute, then what does that imply? Then the measure is between 0 and 90. And let me go ahead and write the other direction. If the measure of an angle is between 0 and 90, then what does that imply? If the angle is between 0 and 90 degrees, then we say it's acute. So it goes either way. Recall that we talked about conjectures in our first unit. A conjecture is a guess based on known information, but it has neither been verified nor shown to be false. We only need one false example called a counterexample to show that a conjecture isn't true. The counterexample could be a number, a drawing, or a statement. Show that each conjecture is false by finding a counterexample. Number one, if x is an integer, then negative x less than x. What is an integer? An integer is essentially numbers that are whole numbers, can be positive or negative, that can be shown on a number line. For instance, -2, -1, 0, 1, and 2. Notice I don't have any fractions. Notice I don't have any decimals. I only have whole numbers, which again can be represented as negatives or positives. So, if x is an integer, then negative x is less than x. What I'm going to go ahead and do is I'm going to show the true part, and then I'm going to provide a counterexample. If x is an integer, then negative x is less than x. So we can say if x is 3, then I'm going to plug it in. Therefore, -3 is less than 3. Well, if we compare these two numbers, yes, -3 is less than 3. That's true. So this is me showing the true part. However, if I show a counterexample where the statement is false, or the conjecture, I can say if -3, if x is equal to -3, then I'm going to, again, I'm going to replace these x's and take into consideration of the negative in -3. So if x is equal to -3, then negative times -3 is less than -3. And then we have a negative times a negative. That's a positive. Which is that less than -3? No, not at all. So this is me showing a counterexample where you can have any negative numbers can be a counterexample. If angle ABC is congruent to angle DBE, then angle ABC and angle DBE are vertical angles. So let me go ahead and show you the true part of this conjecture. So remember, vertical angles are lines that intersect. So these two lines, they intersect, which should look like this, and therefore they are congruent. Angle A, B, D, and here's C, E. So we have angle ABC, and it is congruent to angle DBE. They are across, therefore they are congruent. How many arcs do we need? We just need one, okay? So I just showed this conjecture being true, but remember, there is a possible counterexample. because you don't necessarily or strictly have to have vertical angles to show that these angles are congruent or always congruent. So to provide a counterexample, I would draw something like this. So maybe something like this: A, B, E, and then this will be C, this will be D. And then look, we can just say that these things are congruent. Just like that. That is my counterexample. So congruent, but not vertical. Right? I show that these angles are congruent, but they don't have to be vertical angles. For any x, x squared is greater than or equal to x. So let me go ahead and show you the true part. So let's say x is equal to 4, then I will plug in 4 squared is greater than or equal to 4. 4 squared is 16, greater than or equal to 4. Is that true? Yes. But if I give you something like this, because x can be any number, right? It says for any x, which we can assume true, any x, even a decimal or a fraction, we can say x is equal to 1/2. And if I replace the x's, I get what? I get 1/2 squared is greater than or equal to 1/2, which, well, what happens now is that 1 is being squared and 2 is being squared. So I get 1/4, which is greater than or equal to 1/2. So which one is the bigger number? Well, it's 1/2, right? So here is 1/4 and here is 1/2. Which one has a bigger slice of pizza? Of course, the 1/2. So is this statement true? 1/4 is greater than or equal to 1/2. No. So this is what we call a counterexample. So a fraction could be a counterexample. A conditional statement has a truth value of either true or false. It is only false when the hypothesis is true and the conclusion is false. To show that a conditional statement is false, you need to find only one counterexample where the hypothesis is true and the conclusion is false. Determine if each conditional statement is true. If false, give a counterexample. Number 1, if you live in Terlingua, then you live in Texas. So when we're taking a look at the hypothesis, it is almost always true. So there is a place called Terlingua, and does it imply that you live in Texas? So yes, we are going to assume that the hypothesis is true. Does it imply that you live in Texas? Yes. So that is also true. So if you have a hypothesis that is true and the conclusion is also true, that means that the whole conditional, this conditional statement, is true. Next. If an angle is obtuse, then it has a measure of 100 degrees. So I look at the hypothesis and I'm like, okay, the hypothesis is true. In general, the hypothesis is almost always true. But in this case, yes, there's an angle. We do have angles that can be obtuse. So that is true. So if an angle is obtuse, does it imply that it is strictly 100 degrees? Well, no, because I can provide a counterexample. An obtuse angle in general is above 90 degrees. So I can say 120 degrees. That's a counterexample. If an angle is obtuse, it can also be 120 degrees. Or it can be 135, or it can be 175, right? So this means that if I have a hypothesis that is true and the conclusion is false, then we can say that the conditional, the whole thing, this whole sentence here, is false. Number 3. If an odd number is divisible by 2, then 8 is a perfect square. Well, an odd number cannot be divisible by 2, so that's false. Then 8 is a perfect square. Well, 8 is not a perfect square. If an odd number is divisible by 2, does it imply that 8 is a perfect square? No. So what does that mean if I have a false hypothesis and a false conclusion? Well, that means that the conditional is true. And why is it true? Because it is only false. It being the conditional itself, it can only be false when the hypothesis is true and the conclusion is false, just like number 2 here. However, since we have 3, which is a false and a false, it is not this, and therefore the conditional is true by default.